students. In the previous class, we studied about the basic information of solid state. If you not see that lecture, check the description box and see this. In today's class, we shall discuss more about solid state. So, let's see. First, we see the laws of crystallography. Now, first law of crystallography, that is Steno's law of constancy of interfacial angles. What is Steno's law? Depending on the method of crystallization of a compound, the habit of crystal may be changed, but the interfacial angles will remain unchanged. This is Steno's law of constancy of interfacial angles. Next law of crystallography is Havy's law of rationality of indices. What is Havy's law? To represent the crystal geometry, that is, to represent the geometrical position of the particles which form the crystal in space, three axes are required, which are known as crystal axes. The angle between the crystal axes will depend on the nature of crystal. This is Havy's law of rationality of indices. Next, we see unit cell. What is unit cell? The smallest possible unit of a crystal of a compound which on further breaking produced free particles in the unit of the crystal or unit cell. This is unit cell. Now, next, see lattice. What is lattice? Along each of the crystal axes, the particles are arranged in a regular way. This regular arrangement of the particles along an axis is known as lattice. So, this is the definition of lattice. Now, what is 1D lattice? When the lattice is along the axis, this is an one-dimensional lattice. Now, next see 2D lattice and 3D lattice. What is 2D lattice? When the lattice is along the plane, it is called 2D lattice. And when the lattice is along the space, it is called 3D lattice. Now, we shall study about Weiss Index. Here, we draw the structure. From here to here, the distance is small a. From here to here, the distance is small b. And from here to here, the distance is small c. This is x-axis. This is y-axis. And this is z-axis. From OA, here the distance is p into small a. From this O to B, this distance is q into small v. And from O to C, the distance is small r into c. This is OA equal to p into a, OB equal to q into b, and OC equal to r into c. When p, q, r are the integral multiple, the representation is known as Weiss Index. Students, here we know what is primitive translation. Along a lattice, the unit length which is repeated to describe the lattice is the primitive translation. Now, here when p equal to infinity, the plane cut the x-axis at infinity distance. That means the plane is parallel to the x-axis. When a plane is parallel to x-axis, when p equal to infinity. Next, we see similarly, when q and r is infinity, then the plane cut the y and z axis respectively at infinite distance. For the negative intercept along an axis, index is followed by a minus sign or a bar sign is placed over the index. Now, we shall study about Miller index. What is Miller index? At first, let's take the Weiss index PQR of a plane. Now, first mate reciprocals. The reciprocal of P is 1 by P. The reciprocal of Q is 1 by Q. And the reciprocal of R is 1 by R. In the next step, we multiplied this reciprocal with LCM. What is LCM? LCM is lowest common multiple. And we get QR, PR and PQ. Let's represent this as HKL. This representation of planes by HKL is the Miller indices of the plane. Hello, here we draw a structure. There are two planes A, B, C, D and A dash, B dash, C dash, D dash. Now, let's see, if a plane becomes parallel to an axis, the corresponding Miller indices is 0. When a negative intercept is done by a plane along an axis, the corresponding Miller indices is written with a bar sign at the top. Now, in the figure A dash, B dash, C dash, D dash, Weiss index is 2, infinity, infinity. What is the figure? In this figure, A dash, B dash, C dash and D dash, in this figure, the Weiss index is 2, infinity, infinity. So, how we get the Miller index from Weiss index? First made reciprocals 1 by 2, 1 by infinity, 1 by infinity. So, 1 by 2 and 1 by infinity means 0, 0. Now, multiply this with the LCM. Here the LCM is 2. So, we get 1 by half into 2 is 1, 0, 0. And the Miller index will be 1, 0, 0. Remember one thing, we cannot use comma here. For Weiss index, we can use comma, but for Miller index, we can't use commas. If Weiss index is minus 2, infinity, infinity, then Miller index will be minus 1, 0, 0. And we use a bar sign for negative, and the Miller index will be 1 bar 0, 0. Now, let's see some important notes. The smaller the value of H in the Miller indices HKL, the more nearly parallel the plane is to the x-axis. Similarly, smaller the value of K, the more nearly parallel is the plane to the y-axis, and the same is true for L to the z-axis. So, what happened? The smaller the value of H in the Miller indices, the more nearly parallel the plane is to the x-axis. Similarly, we get the parallel of y-axis and z-axis. Next important note is, when H equal to 0, the plane intersect the x-axis at infinity. When H equal to 0, the plane intersect the x-axis at infinity. So, when 0KL, so the 0KL planes are parallel to x-axis. Similarly, the H0L and HK0 planes are parallel to the y and z axis respectively. Here HK0, so the plane is parallel to z axis, and here H0L, so the plane is parallel to y axis. Now we do some problems. First question is, calculate the Miller indices of a crystal plane which cut through the crystal axis at 2a minus 3b minus c. Coefficient of ABC are 2, 3, 1 respectively, and Weiss index is 2, minus 3, minus 1 or 2, 3 bar, 1 bar. Now, how we get the reciprocal from Weiss index? First made reciprocal 1 by 2 minus 1 by 3 minus 1 by 1. Multiply with LCM 1 by 2 into 6 minus 1 by 3 into 6 minus 1 into 6. So we get 3 minus 2 minus 6. So the Miller indices is 3 minus 2 minus 6 or 3 2 bar minus. A face makes intercepts 2A and 3B on the x-axis and y-axis respectively and does not cut the z-axis at all. What are the Weiss indices and Miller indices of the plane? This is the next question. So, coefficient of ABC are 2, 3 and infinity respectively. So, Weiss index is 2, 3 and infinity. Now, we want Miller indices. So, first we made reciprocals of Weiss indices. Half, 1/3, 1 by infinity. That means half, 1/3, 0. Multiply by LCM. Half into 6, 1/3 into 6, 0 into 6. So, we get 3 to 0. So, the Miller indices is 3 to 0. Next question is, the Weiss indices of a crystal plane are A, B, infinity. Calculate the Miller indices of the plane. Weiss indices is 1, 1, infinity. So, Miller indices, first we made reciprocal. 1 by 1, 1 by 1, 1 by infinity. That is 1, 1, 0. Multiply by LCM. Here the LCM is 1. So, a 1, 1, 0. And we get the Miller indices 1, 1, 0. So, students, I think you understand this lecture.